Hello, everyone. Thank you so much for coming here. It's fantastic to see so many people. This is just kind of overwhelming, but we'll be OK. So thank you very much for coming. I'm Mark Sales. I'm a solutions architect at AWS, and I specialize in the serverless services. So API Gateway, Lambda, SNS, SQS, things like that. And I also really enjoy Java, and I've been programming in Java for a long time, ever since I've been at university. And I work with a lot of customers who are looking to adopt AWS Lambda and have lots of Java applications. And I really work with those companies to look at how they can bring those applications from either EC2 or from their own data centers or from containers and bring those onto AWS Lambda. And I really enjoy that work. It's really, really interesting work. But it can be frustrating at times. So if you've been one of those frustrated customers who's used Java and Lambda before, this is the session for you. OK? So hopefully we're going to tell you about some really cool new stuff. Lambda SnapStart for Java. And hopefully we'll make that journey to Lambda a little bit easier. So I said I've been using Java for a long time. Probably about 20 years now, which seems like an incredibly long time. And I've enjoyed it for many different reasons. You know, I've enjoyed the language. I've enjoyed the community. I've enjoyed all the free code that I get from all the amazing open source projects. You know, I've really built some fantastic things with the code that people have shared over the years. But I've noticed over the last few years, but there seems to be this really renewed surge in Java. And I think one of the reasons for that is the release change, the cadence change that came to Java in the last few years. So instead of having long periods between releases, we now get 2 releases every year, which I think is just fantastic. So it's really borne out a whole heap of new innovation. So things like Project Loom and Project Laden and Project Crack, which is a proposed project, which we're going to talk about later. And I'm really enjoying this renewed interest in Java. I think it's fantastic. This is a kind of a histogram graph of the number of requests at a low latency and a high latency. And this is a really exaggerated graph because I've had to put it onto a slide to show you all. But what it's really showing is that the vast majority of requests actually happen really quickly. But there's a small number of requests that actually have a very long latency. And that's really frustrating if you're building customer-facing APIs or something that requires a really responsive interaction. So to demonstrate this new functionality, I've put together a really simple Spring Boot application. So I've got a Spring Boot application that takes requests from API Gateway, processes them in a Lambda function, and then I'm storing and retrieving information from DynamoDB. So just like a lot of Spring Boot apps you might be familiar with, I have a controller with a bunch of MVC actions. I have some business logic in a service, and then I have another class that calls DynamoDB for the various operations. And for the majority of the time, I get warm starts and very fast invokes around 10 milliseconds. And this is the vast majority of our calls. But occasionally, I'm going to get much slower responses. And these can be in the order of seconds. So in this example, I've got a 6.5-second cold start and a further 600 milliseconds to invoke my function. And in reality, this is a very small percentage of invokes, but that's still frustrating for our customers who are using our APIs. They always want to have a fast, responsive use of our systems. So we really want to try as best we can to reduce our cold starts and have a really responsive application. But before we dig any deeper, let's just talk about maybe why that's happening. So what is it about Java that has this specific characteristics? Well, when we make a new execution environment for Lambda, we're doing the same things as other runtimes. So we're creating the Firecracker instance, we're downloading the code onto that instance, and we're starting the Java runtime. But then Java is doing some Java-specific things. So it's doing the class loading of your classes into the JVM. If you're using a framework that uses dependency injection, it's doing quite a lot of reflection and working out what should be where and what to do next, and that takes time. And also Java is taking your bytecode and compiling it to run natively on your machine. So all this takes time, and this is a first invoke issue, and this happens when you create a new execution environment. So before SnapStart, people would spend time looking at each of these areas, and there'd be different optimizations that you could do in order to mitigate some of these issues. So people would look at the dependencies that they were using for their applications and maybe try tailoring them down. So maybe I don't need a really complicated logging system. Maybe I can use SLFJ simple, and maybe with less features, I'll have a faster startup time. With dependency injection, there's lots of really cool frameworks that do dependency injection. And some of them run at runtime, and some of them run at build time. So Micronaut, Quarkus, Dagger are all dependency injection frameworks that do all the dependency injection at build time. And that means there's less work to do at the first invoke of a Lambda function, which is really important. There's also ways to help the just-in-time compilers so that they have a faster experience as well. So with your Lambda function, if you specify that the Lambda function has more memory, it's also allocated more CPU at the same time. And Java really needs CPU at the beginning of its invoke to compile all of your bytecode into native. So it really needs that CPU right at the beginning. So if you're having slow cold starts, adding more memory is a really, really simple thing to do to have a faster performance. And again, we published a blog this year about tiered compilation, which is a feature of Java that allows you to change what the compilers are doing when. And we found that actually some of the compilation activities are best to be tailored down so that we have a faster first invoke. And then right at the end, we're talking about ahead of time compilation. So we can do all of the compilation of our Java code ahead of time, produce a native executable, and invoke that instead of a Java function. And really, all of these optimizations come down to various amounts of effort to do various amounts of improvements to your cold start. So we have, on the left-hand side, things that require more code, more config changes, and are maybe easier, less effort to do, and they'll get you so far. But actually, to get the really fast cold starts, you actually need to make larger changes to your code. And this is where we really think we can help innovate and help our customers by innovating in this area to provide something that's completely different. How can we really produce much faster cold starts for your Lambda functions? So this is AWS SnapStart, up to 10 times faster performance for your cold starts. So we really want to make it easy for you to build highly scalable applications with really responsive feedback. How this is going to work is that when you enable SnapStart for a function, so it's not enabled by default, you make a config change to your Lambda function at a function level. When you create a function version, then we're going to take your code and initialize it. And once the initialization is finished, we're going to take a snapshot of the entire virtual machine that function is running on. We're going to store that snapshot encrypted in our own data store, and then we're going to load that snapshot into a series of tiered caches for low latency retrieval. While that process is happening, the function version will be in a pending state. That means that the function won't be able to be invoked. Once the snapshot has been taken, this will be changed to an active state, and you'll be able to invoke the function. When you come to invoke the function, it will restore the execution environment from the snapshot, and then the invoke will happen. And in the same way today that you can spawn lots of execution environments really quickly, the same is true with SnapStart. All future execution environments for that Lambda version will be created from the same snapshot. So you'll get multiple resumes as your traffic increases. The more and more execution environments will be created to handle the traffic as it comes in. And each time, there'll be a resume from the snapshot, and then you'll get your function invoke. So let's dive a little bit deeper now. We'll talk about the new invocation model. So the invocation model has changed very slightly. So in the same way, we're still going to, when we create the snapshot, we're still going to do the same sort of steps, but we're also going to give you an extra opportunity to run specific code that you want to run before the snapshot is taken. And I'm going to talk about why that might be important a little bit later. But we found in testing that it's actually really important to give customers the opportunity to run their specific code at specific times, and that's really useful. So there's going to be a specific hook before and after the snapshot is taken. So this is the pre and the post snapshot hooks. So my Lambda function, my Spring Boot application, is taking a request over HTTP and writing to DynamoDB. I moved from a cold start of around 7 seconds for my example application to a first invoke of 950 milliseconds, which I think is a really fantastic change for a simple config change. So this is a really, really cool improvement, and I think you'll really find it interesting to try it. So let's just go over how you might try it on your own functions. So in general configuration, there'll be a new item, which is called SnapStart, and it has a single option, which is called publish versions. So you can go into the console, it's available today, and select your function, configure it for SnapStart. If you're using SAM, this function is available today for SAM. You can add the SnapStart attribute to your YAML file and publish in the same way. And this is what it will look like with CDK as well. So let's just talk a little bit more about the versioning. So I mentioned that SnapStart requires function versioning. If you're not used to using versions, this is something new. If you're integrating two services, so for example, API Gateway to AWS Lambda, you might be used to connecting those two services with the function version ARN. With SnapStart, you need to specify the version that the SnapStart process has been enabled for, or an alias to that version. If you don't specify either of those, it won't invoke the SnapStart function. It will invoke your normal on-demand function. So if you're trying this for the first time and you don't see any change, just double check this, okay? Make sure that you're invoking the function version. Okay, so I mentioned the hooks. Let's talk about how this will actually happen. So we've got the opportunity to run code before and after the snapshot process. This is an example handler written in Java, and I've also added an extra interface here So you'll see the resource interface. So this isn't an interface that's available in OpenJDK. It's part of a project called CRAC, which stands for Coordinated Restore at Checkpoint. And it's a proposed project for the OpenJDK project. So it's not available in OpenJDK yet. It's an external dependency that you add to your Lambda function. Then you can implement resource, and you'll see that there's 2 extra methods for this handler. This can be added to your handler, or it can be its own class. And here, very simply, I'm just printing out some messages, but this could be any code that you have that you want to run before and after the snapshot. Okay, so why would I want to run code before and after my snapshot? Well, I just want to tell you some of the things that you might want to consider. So we're changing the way that Lambda functions are created, and we're now restoring from snapshots. So each environment is going to be the same. So there's really 2 or 3 things that you really want to think about when this is how you program. So the first is network connections, second is ephemeral data, and the third is uniqueness. Let me give you some examples just to talk through these. So say I have a Lambda function, which is speaking to an RDS database. In my init phase, I might eagerly connect to that database so that the connection is ready when I make my first queries or my first writes. If I make this connection eagerly, then my snapshot is going to have a memory that this connection is made. When I resume from that snapshot, I could be on a different host, it could be weeks later, that network connection won't exist. So when I come to invoke the Lambda function, I'm going to get a connection failed, and I'm going to retry. So this is an important thing to consider. This isn't a new problem. This could happen to Lambda functions today. Your network could have an issue. Your Lambda function could have a different timeout to your database. There could be a number of different reasons why this might happen. But this is a new way that this error could surface. So it's a really good thing to think about. A lot of applications, when they're making database connections, they have inbuilt functionality to make retries. So we found in our own testing, when we've been using various open source connection pooling libraries, that they are perfectly fine with being snapshotted. Once they resume, they realize that the network connection isn't there, and they retry. Okay, let's talk about ephemeral data. And by ephemeral data, I mean data that might change over time. So for this example, I'm going to talk about Secrets Manager. So I might connect to Secrets Manager to get a database password or some other sort of application configuration that I want to keep secret. Maybe it's a password to another API endpoint. And I might retrieve that eagerly because I only need that once. So I'll grab that in the init phase. Again, if I'm using SnapStart, that secret is going to be saved into the snapshot. If in the future that secret is rotated, my snapshot is still going to remember my initial value. So I could get an error, something like incorrect credentials. My Lambda code needs to be aware that that might happen, and it needs to go refetch those credentials. And it's the same. This could happen today with regular usage of Lambda, and you should be able to be aware that this may happen, catch the errors, and continue. But again, this is a new way that this error might surface. So be aware. And then finally, we're creating new execution environments from a snapshot. You could well think that that might cause problems with randomness or uniqueness or cryptography. We don't want to have the same seed when we're producing random numbers. AWS has made updates to Amazon Linux 2 and OpenSSL so that they are resilient to the snapshotting process. If you're using host best practices for producing random numbers, then this is the way to do it. Something like OpenSSL, dev random, dev urandom. This is the best ways to produce cryptographically safe random numbers. And we've tested these. We've also tested that the Java 11 runtime using Java security secure random is snapshot aware. So producing random numbers in this way will continue to work. If you're producing random numbers in another way, if you produce your own mechanism for producing random numbers, then this is where I would look at your function code, try testing it, and if there is a mechanism where you're not producing random numbers and it's creating random numbers that are predictable, then this is where I would use some of the hook functionality to make sure that that is reset so that your random number code continues to work. We're also producing an open source project which will use the SpotsBug plugin to help find potential anti-patterns. So if you're using something like Java util random, this is not cryptographically safe, and this could be a source of errors if you're using snapshotting. Okay, so I've tested out this sample application, and I've produced a small test which fires in 100 requests a second for 10 minutes. So I'm starting from a completely cold application, and I'm just firing in a whole heap of requests. So this is a real test for Lambda because it's just going to go from 0 to 100 straight away. Before SnapStart, this was my results. So my average response time was really fast, 8 milliseconds. But my tail latency, my 99.9% latency, was over 5 seconds. With SnapStart, my P50, my average, is still exactly the same. But my tail latency is much reduced. So 536 milliseconds. I think that's a really fantastic improvement. And this is where we could kind of end the talk, but this is a level 300 talk, so I think we can go a bit deeper and talk about some more interesting things as well. So let's really think about what Java is doing and what we can do with this new functionality that we have. So Java is doing class loading, dependency injection, and just-in-time compilation. Okay, so I can produce a resource with some hooks, and I can do some interesting functionality with this. So I've got my application, which is making requests to a unicorn store to read and write unicorn records. And this is an example of a Spring-style class, which implements the runtime hooks. So I've got my @configuration annotation, which is going to produce a singleton of this class. When that happens, I'm going to register this class with the runtime hooks. So I'm going to do call get global context register, and that's how this class is known by the runtime to do the before and after hooks. And then you'll see in the before section, I've got a reference to my controller. I'm going to make a fake request to that controller. And because I'm the application developer, I know that this is a safe operation, okay? So I know that making a dummy call to a get operation is safe. And what this is doing, this allows me to really execute all of the code paths in this functionality. So it's gonna execute the controller, it's gonna invoke the service, it's gonna invoke my DynamoDB repository, and then it's gonna call DynamoDB with the AWS SDK, which means all of those code paths are going to be initialized and compiled. And this is going to happen before the snapshot is taken, which means that the next time my function is invoked, all of that code will be compiled and really ready to go. So I now go from a cold start or a P99 of 536 milliseconds all the way down to 488 milliseconds, which is fantastic. So even doing nothing, I really get fantastic performance, but also we give it the ability to look at your application, and if there's any other information or other actions that can be taken, you also get the ability to do this. Okay, so this is my simple test, but we've had, luckily, some other customers as part of the beta program who have also been involved in this, and here's a couple of quotes from them, so I'll let you read these. I think this is really fantastic. There was definitely use cases that were very difficult to achieve with Lambda. I think SnapStart really helps you to make that gap more and more easy to achieve. And just one more from Bill.com. This is a really high throughput system, 6.5 million invocations per day, and improved cold start performance by 95%. I think that's fantastic. Really cool. Okay, so if this has maybe interested or renewed your interest in Java and renewed your interest in Lambda, I'm also going to tell you about another open source project that I'm involved in. And this is called Lambda Powertools for Java. Lambda Powertools is an open source project that really helps developers implement Lambda best practices as easy as possible. And we have a set of tenets that we're really proud of that guides the direction that Powertools goes in. So Powertools is a framework and a set of client libraries that is just AWS Lambda focused. So we don't focus on any other runtimes. We don't focus on containers. We're just producing the best practices for Lambda. And over the years that Powertools has been available, we've listened to the community, and we've listened to what people have been telling us, and what people have been finding hard, and what people have been finding difficult to produce, and code that they've been producing over and over again, and they wish that they could have from a framework. So we've produced a whole heap of different functionality for Powertools. If you're interested in Lambda SnapStart and you'd like to take this away and try it, then we're going to be updating our Lambda workshop for Java in the next few weeks. We're going to add a whole section on SnapStart, and this is something that is available publicly, although it's not ready right now. If you keep checking, hopefully this will have a new section all about SnapStart, and this will take you through a step-by-step guide of how to take an application and enable it for SnapStart and see the results. And if you like this session on Java, then I have another session on Thursday, which is called Effectively Using Java on Serverless. And this is a chalk talk and a real opportunity to go deep into some specific areas and ask a whole heap of awkward questions. So if you'd like to come, I'd love to have you there as well. So thank you very much for listening.